I hope you're ready, because now it's time to train a model on the full data. We verified that everything is working by going through, checking our model's predictions, evaluating them and going, yep, our model is definitely learning something, but since we've only trained it on 1,000 images, let's see if we can train a full-scale model, like our first full-blown deep learning model training on 10,000 plus images. And this is where the power of the functions that we created earlier are really going to come into play. So let's make a little heading for ourselves. Training a model. Actually, let's call it training a big dog model. And we might put a little emoji here on the full data. And you get it, it's a big dog model because we're training on lots of images of dogs. I love this project. Now, code. What we need is, remember right up the top, if you don't, that's okay, we're going to have a look at it now. We have X and Y. Len X, len Y. And this is all of our training data. These are the file names and these are the labels. So if we come up here, X is all of the file names in train. So if we have a look at the first maybe 10 of X, 10 of X, these are all our training image file names. We split these before into xtrain, which is only 800 in length. There we go. So if we have a look at len xtrain, only 800 images. So at the moment, our model has only trained on 800 images. And if we want to have a look at Y, Y is the labels associated with each file path in the form of Boolean arrays. So what do we need to do to train a full model? If we come back to our keynote, what's our workflow? Get data ready, turn it into tensors. Well, we've got a function for that. Do you remember create data batches? If you don't, it's all right. We've created a function for that. And we got pick a model to suit your problem. So TensorFlow Hub, we've got that. We can just use create model and then fit the model to the data and make a prediction. Let's give it a crack. So let's go create a data batch with the full data set. So this is where functions really help out. Is later on in your notebook. I told you it was worth it. Full data equals create data batches. Look at this. This is our function that we've written above. Creates data batches of data of image X and label Y pairs. Beautiful. Shuffles the data if it's training, but doesn't. Well, that's a bit of a hindrance. We can't see that. Also accepts test data as input, no labels. So that's all right. This is not training data. So let's create a full data batch. Now we have a look at full data. It's a batch data set. Beautiful, with images and labels. Wonderful. And if you're wondering what create data batches actually does, let's go right back up. If we have a look at our index here, what are we doing? Visualizing data batches, turn our data into batches. So here's our big function, create data batches. It takes X and Y. And here's what's happening. This is because it's a training data set. Creating training data batches. Turns X and Y into tensors. It shuffles them. And then it maps our processing image function as well as get label function to the data. And then it turns the data into a batch size of 32. But we've already seen a video on this, so if you need a refresher, go back and check out the video where we created this function. So let's come back to where we were. So now we've got our data batch. What's the next step? Well, we need a model. So let's do create a model for full model. Full model equals create model. Remember what our create model function did? Oh, no docstring. Well, let's run that anyway. We can go check it out. So building a model with tfhub.dev ImageNet MobileNet v2. So we've got a model. Okay, we've got a batch data set and we've got a model. Now, if we want to check out what create model does, where is it? Building a model. If we come down here, this is our create model function. It doesn't have a doc string. Maybe that's something you could add. So create a function which builds a Keras model. So what it's going to go through is go through the steps that it took before to create a Keras sequential model using the model we downloaded from TensorFlow Hub and a dense layer on the top to make sure our outputs are the same size as the labels that we have. It's going to compile the model with a loss function, an optimizer, which is our friend Adam, the guy at the bottom of the hill telling us how to descend down the hill at the International Hill Descent Championships. And metrics is accuracy is what we're measuring. And then we're building the model, feeding it the input shape, which is the size of our image. Wonderful. Come back. So how might we train this? What's next? What do we do next? Well, we created some callbacks. So we might have to make some specific callbacks for our model. So let's do that. Let's go create full model callbacks. Full model TensorBoard equals create TensorBoard callback. There we go. There's our function from before to create a TensorBoard callback. Remember, the TensorBoard callback helps us to track the performance of our model and compare it to others. And so there's no validation set when training on all the data. So with our early stopping callback, we can't monitor validation accuracy. So for our early stopping callback, we need full model early stopping equals tf_keras dot callbacks dot early stopping. There we go. And we're going to get it to monitor accuracy. When our model is training on the full data, when its accuracy stops going up for 3 epochs, we're going to get it to stop training so it doesn't overfit, or we're going to try and prevent it from overfitting too much. So shift and enter. Wonderful. Seems like we might have a recipe to start training our model. So fit the full model to the full data. So here's where we can go. We can go full model dot fit. So we're just calling the model we created. Dot fit. X equals the full data. Now there's no validation set, remember, because we're training on the full data. Epochs is going to be 100, or it could just be num epochs, because we've set num epochs before. And we're going to have callbacks, which are the 2 callbacks we've just created. Now this is just doing the exact same steps as what we've done training a smaller model, but this time with more data. Wonderful. And now I'm going to put a little note here to give you a little heads up, and well, I'm going to speak it out so you know as well. Running the cell below will take a little while. Maybe up to 30 minutes or maybe a little bit longer. 30 minutes for the first epoch, because the GPU we're using in the runtime has to load all of the images into memory. So the first epoch, remember with our smaller model on 1,000 images, the first epoch took a couple of minutes, maybe 3 or 4 minutes. As you could imagine, because this one's on the full data set, it's training with 10,000 images. So it's going to take a little bit longer to load all of the data for the first epoch. So before we run this, as long as all the code's correct actually, it might error out. That's why, rather than train on the full data from the beginning, we've made sure everything works. Because when training a full machine learning model or a full deep learning model, it can take a fairly long time. And ours, we're pretty lucky here. This is going to train within an hour because we're using a GPU. But you could imagine if you're working at a bigger company, you might leave something training for a week. So that's why you want to make sure that when you set up experiments, imagine training a deep learning model for a whole week, and then it turns out that it wasn't working. So that's why we did all of the steps above to make sure that everything's working. So before we train a massive model, we can be sure, okay, things are in place. Let's kick off a full training round. So you ready? We're about to train our first full-blown deep learning model on 10,000 plus images. Dog vision is truly becoming a reality. Hit it with me. 3, 2, 1, shift and enter. Fingers crossed, hopefully this works. We should see a little loading bar come up. And because we've set number of epochs to 100, it's going to keep training for up to 100 epochs. But if it stops improving, we've got our full model early stopping callback that's going to stop it training early. And then we can check the results using TensorBoard after it's finished. So we'll just wait for this to kick off. And then what I'll probably do is pause this video because it's going to take about half an hour. I'm going to take a little break. Maybe you could too. Have a little walk around, chill out. Oh, maybe it's going to take a little longer than half an hour. This timer should go down unless my testing is incorrect, but we'll wait a few seconds. And then I'll come back to this video once the model has stopped. So once the model early stopping, the full model early stopping callback has kicked in. Okay, so I'm going to let this run for as long as it needs to run. I'll come back once my model has stopped itself thanks to the early stopping callback. So I will see you in a couple of seconds, but for me it's going to be a couple of hours in the future. Maybe it's a couple of hours in your future as well. And we're back. Alrighty, so let's have a look at our fully trained model. As you can see, my first epoch took a fairly long time, and this is actually, I need to take a moment. If you've finished this, if you've gone through this, you need to pat yourself on the back because this is like a rite of passage, training your first end-to-end deep learning neural network. And it's taken a long time. One of the things you'll have to figure out when you become a data scientist or machine learning engineer is ways to pass the time whilst your model trains. So I went for a walk with my dogs because this took what? How many seconds is that? So 4,730 divided by 60, 78 minutes. So just over an hour to do the first epoch, but as I said, after the images are loaded into the GPU's memory, check out how fast it goes after that. And what you'll probably want to do is as this cell is running, I should have told you this before, but you can take note for the future. As this cell is running, you want to have a save model running after it. That way, once your model stops training thanks to early stopping, our early stopping callback up here, it's going to automatically call our save model function and save our full model to our models directory. Now let's come up here and have a look into models. Oh, I've got a few there. So let's see, it's going to be the one with the, there we go, full image set, MobileNet, 2nd of February. And I started at about 5 p.m. So this time is actually wrong for me because I'm not sure, maybe date time is getting the wrong time for me. But there we go, that's saved here. We've got our path. So now we can have a look. Our model actually ended up doing pretty well. Look at that, that's training accuracy. But I'm a little bit skeptic here. You know why? Because we aren't validating this. This is just a model training on the full training data. So let's come here. It's training on all the images in this train file, aka X and Y. And so we can't really test on a validation set. But what we can do is import the test data set that we originally downloaded from Kaggle. Here we go. The test file. And we can import those, turn them into a data bunch, and then use our model to make predictions and submit them to Kaggle. How epic is this? So our model is saved. Let's test our load model function. So loaded full model equals load model. We're just going to copy this path here. We'll go there, load in the full model. And if we copy this line here, tick. Oh, we don't want to put it there. We want to put it in here as a string. Let's check that out. Wonderful. That's going through. That's what we're after. So again, we're getting those warnings that the TensorFlow documentation says can be ignored. Alrighty. Now, what's next? Well, I think now that we've got a fully trained model on all of the 10,000 plus images, I think we see how to make some predictions on the test data set. So let's do that in the next video.